All right, so is it okay last night not having any homework for me? Yeah, sweet. Today, just so you guys know my schedule, I am heading out to Smoky Hill right after this class, then heading out to Overland, and then I'll be back in my office by noon. So that's my schedule today. So some of you still need to finish up the quiz before you take it. So let's get on the ball with that, please, as soon as possible. So let's continue with these notes, and then we're going to work on worksheet 14 in a little bit. But I want to let's figure out what we have here. So it says that 2 to the 5th is 2, 2, 2, 2, and 2. And if I multiply that all together, I wind up with 32. And then I have 2 to the 4th is 2, 2, 2, 2. And that's, if I multiply that all together, I get 16. So let's see. Gabe's not here. So who's going to pick on this today? Kieran, what's 2 to the 3rd? Tell me about it. So 2 to the 4th is this. What's 2 to the 3rd?
Like, how many clouds?
Yeah, what does it look like? So what would this blank be? If 2 to the 4th looks like that, what does 2 to the 3rd look like? Yep, there you go. So 2 times 2 times 2. And 2 times 2 is 4 times another 2 would be 8. Okay, good. All right. And then 2 squared, that's pretty simple. Megan, what do you think? 2 squared, how does that look on that next line down? 2 times 2, which would give us 4. And then 2 to the 1st means I have a single 2. So that would be 2. And we have to think about what this means. 2 raised to the 0 power. And a lot of kids, when they see 0, their go-to immediately is 0. But unfortunately, it's not. But before we answer that question, let's go to what 2 to the negative 1 means. This means I have a negative exponent, which means I'm going to create, where this is sitting, is 2 the same thing as 2 over 1? Is that the same thing? Okay? So if I have 2 to the negative 1 like this, and I could write this, that means I want to move what's up here down. So then if I move everything down, I'm left with a single unit. So this becomes 1 over 2 to the 1 over 2 to the 1st. So this is 1 over 2 to the 1st, which is just 1/2. But then if I had 2 to the negative 2, that's going to be the same thing as 1 over 2 to the 2nd. And 2 to the 2nd is 4, so this becomes 1/4. And then 2 to the negative 3 is 2 to the 1 over 2 to the 3rd. 2 to the 3rd is 2 times 2 times 2, which is 8, so this becomes 1/8. Okay? So let's think about this. What's coming right here? So as I went further, if I got 2 to the negative 4, that becomes 1 over 2 to the 4th. And 2 to the 4th is 16, so that becomes 1 over 16. And as I continue, the next one would be 1 over 32, 1 over 64, 1 over 128, 1 over 256, 1 over 512, 1 over 1028. So the fraction is getting to be a really small fraction. But when I say a really small fraction, what number am I approaching if I'm dealing with a fraction? What number do I approach? So let's say I have a sandwich and I cut it in half. And I take half and I give half to my friend. I understand you're a high schooler, so that shouldn't be happening because I want the whole sandwich. But then what if I were to take that sandwich and it was myself and 3 others, and I were to cut that sandwich into four equal parts, so 1/4. Or if I had 8 friends, so then I cut it into 8 equal parts. What can you tell me about each one of those parts of that sandwich? Are they getting bigger or are they getting smaller? Smaller. I mean, you're going to get to a point where you really couldn't slice that sandwich any thinner, nor is it worth it. to do. So as I get 2 to negative infinity, that becomes 1 over 2 to infinity. And infinity is a really big number, right? So 2 multiplied by itself, this is approaching 0. I'm trying to get to 0. Okay? If any of you go into philosophy as a major in college, there is something known as Zeno's paradox. Z-E-N-E or Z-E-N-O-T apostrophe X. Zeno's paradox. And it talks about a frog that happens to live on a log. Okay? I mean, it's as simple as that. You have a log, a fallen over tree, and a frog at one end of it. Well, that frog is able to leap half the distance of the log, and then leap half the distance of the remainder, and then half the distance of the remainder, and half the distance of the remainder. Does the frog ever get to the end of the log? Mathematically, no. In life, yeah. I mean, if I wanted to say, I want to make half the distance between me and that door, this is about half the distance that I was just standing. If I wanted to make up half the distance again, if I want to make half the distance again, 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 it's getting really small steps I have to take. Okay? So, let's think of this. 32, 16, 8, 4, 2. Still thinking about it. And then half, fourth, eighth, 16th, 32nd, 64th. What number do you think is going to fit right here? Yeah. 1. So 2 to the 0 power, our place is going to be the fulcrum of our place. We are balancing all the numbers above it and all the numbers below it, but all the numbers below it are between 0 and 1. So 2 to the 0 power. So if I have some numeric value and it's raised to the 0 power, the answer is going to be 1. If I have x to the 0 power, the answer should be 1. Okay? So Preston, a to the 0 is 1. Christian, 7 to the 0 power. Andrew, b to the 0. Garvey, 20 to the 0 power. Kieran, m to the 0. George, 6 to the 0. Okay. Tristan, wakey, wakey, eggs and bakey. The Greek letter pi raised to the 0 power. Anybody? 1. 255,321 raised to the 0 power is 1. Here's the trick. 0 raised to the 0 power. It seems like it should be 1 because everything else was 1.
Is it 2? It's probably
0 raised to the 0 is an undefined term. It cannot exist.
But we just made it exist.
Oh, I understand.
But if it's like
Which
It hasn't existed till now.
in later math classes, it's called a limit. And then in the class of calculus, there's different theorems. One's called the squeeze theorem. One's called the fly-swatter theorem. It means the same thing. You're approaching it very closely, but you're not getting to it.
what if it's like 0 to the 8?
0 to the 8th power. I think that would just be a 0. But 0 raised to itself is undefined. 0 raised to a numeric value is going to be 0, though.
So we would say no solution.
0. No,
No,
0 is
zero,
it.
0 to the 0 power.
So
Like,
no
if we
solution
have or
versus undefined. Gosh, I think I would say undefined means different than no solution. Because on a no solution answer, like if we were solving the problem 3x plus 2 equals 3x plus 10, and we subtract 3x, we get one number equaling something totally different. So there's not a solution that would exist there. But then something that's undefined, we haven't defined in math. And you would think, 0, come on, define it already, math people. All right, let's move down a little bit. X to the third means, Casey, what does x to the third mean? Yeah, how would you write it out? Yeah, I like it. X times x times x. Simplified really is x to the third, so I can't go much further. X to the second. Celine? X times x. X to the first, shout it out. X to the 0, shout it out. 1. X to the negative 1. Close.
X, oh, 1/2 x.
Can I just say 1 over x for now? Now what's that? 1 over x to the what? Second. What's that?
1 over x to the third.
Okay? So these are approaching what number? If I'm getting to a fraction to get to a small number number being 0, okay? And here's the hard thing. A lot of people think, well, small numbers should be negative. The only difference between a negative number and a positive number is the sign. A negative number is a certain distance away from 0, and a positive number is a certain distance away from 0. And you guys learned a long time ago that we can't have a negative distance, right? So it's like, how far is it from here to go over to the 7-Eleven? And you might have someone say, well, it took me 1,084 feet to get there, or 1,084 steps or something. I don't know. I'm just making something up. Well, does that mean the person to get back here took negative 1,084 steps? No, they took the amount of steps. It was a distance. So a positive number is a distance away from 0, and a negative number is also a distance away from 0. So it's a way to start thinking about that a little bit. Okay, so x raised to the 0 is equal to 1, and x raised to the negative n power is the same thing as 1 over x to the n. So a negative exponent wants to switch spots. So I want to focus on this for a sec. It wants to switch spots. So what does that mean? It means this. Let's say I had 7x to the negative 2, y to the 5th. We have a negative exponent. Right now that whole number is written all in one string. I could put this whole thing over 1. The x to the negative 2 is a negative exponent. It's not happy where it's at. It wants to switch spots. So this right here is going to move. Once it moves, it's going to become a positive exponent. The 7 and the y to the 5th are content. They're not negative exponents. So 7, y to the 5th stay on top. X to the negative 2 moves down. Once it's moved down, it's in a happier location. It's not a negative number any longer, or negative exponent any longer. Okay, another example that would go with this would be, let's say we had 5x to the negative 3, y to the negative 2. First things first, does 5 have a negative exponent attached to it? No, it's content where it lives. So the 5 is going to stay up on top. What do you think y to the negative 2 does? It goes on top. It's now swapped spots, so it's going to be a positive exponent. What do you think happens to x to the negative 3? Goes down. Is it negative now that it's moved down? No. Okay? So a negative exponent is going to change its location. If you have a number such as this, x to the negative n, so if we had 5 to the negative 2, that's the same thing as 1 over 5 squared, which is the same thing as 1 over 25. So what you will do in these situations is you're going to realize that the number is over 1, move it down. If you move everything down, you have to have a placeholder in place called 1. I think I'm okay so far. Are you feeling okay? A couple of you are praying, I think. Because I wouldn't think you're falling asleep. All right. Let's figure these out. Coming around the room, everyone is game. So make sure your neighbor's awake. If not, let's shave their eyebrows off. All right, ready? Steve, coming to you first. 4 to the negative 2. What do you think? 1/4 to the second. I love it. So 1/4 to the second power. Let me go escape. So 1 over 4 to the second power. And what do you feel that 4 squared would be? No? What is 4 to the second power? Which is? Almost 16? Okay. All right. Tyler. X to the negative 5th. How are we going to make it a little bit happier?
1 over x to the 5th.
Sweet. You're absolutely right. 1 over x to the 5th. And I can't simplify because x is a variable, right? I'm not multiplying anything out. Okay. Andrew, coming to you. Let me move it over so we can see it a little better. Can you see that okay, or do you need to zoom more? Sweet. Uh-oh. There we go. So I have 3 minus 4 in parentheses as an exponent. So what does that simplify to? Negative 1. So that really is z to the negative 1. And z to the negative 1, a better way to write it would be? No. So you're saying z to the negative 1. That is x to the negative 5. Look what happened to the x. Where'd it wind up? But we're losing the negative. So realize this is gone. So it's 1 over z to the first, which is the same thing as 1 over z. Is that okay to say that? So this was z to the negative 1, which is the same thing as 1 over z to the first, which is the same thing as 1 over z. Is it wrong if you leave it as z to the first? No. Okay. All right. Megan, what do you feel that y to the 0 would be equal to? 1. What do you think that 1 over y to the 0 would be equal to? 1. Right. So exit. So this is this downstairs. I get 1 on top, and then I get y to the 0, which is 1. 1 over 1 is the same thing as 1. Okay? George, number 5. What part of number 5 is going to be 1? Would you feel? Y. Because y to the 0 is 1. I like that. Is there anything that's unhappy where it's at? Z. What's Z going to do? Down? Sweet. It's going to move down. I like it. All right? So this portion here is just going to give me 1. So that would be x to the 7th times 1 times z to the negative 2. And George said this is going to move down. So I'm going to get x to the 7. There's still a 1 there. We don't have to write it anymore. And then this is moving down to a denominator. It's not content where it's at. It's in a negative situation. So now it's moved down. Okay? Kenzie. Let's see if I can get number 6 blown up so we can see it nicely. Can you see that?
Not really. It's really, okay, that's better.
Looking better?
Yeah.
Is that a to the negative 3?
Not-
It looks like an S. I can't tell.
Dude, what is that? Let's just do this. Mackenzie, what would you like that negative? What would you like this to be?
A 3.
A 3? Okay. A negative 3 is okay?
Yeah.
All right. So that's 1 over a to the negative 3. Just because we can't really see it, it's like, I even zoomed it and it still looked bad. What do you feel?
Should we do? I don't really know.
Okay, take a thought. It's a negative exponent, so what is it going to want to do?
It's going to want to become positive.
It's going to want to be positive, so what does it have to do in order to get positive? Does it have to move?
It has to move.
Okay, so where should it move?
The top.
Top. Okay, so this is going to move, right here is going to move on up. This doesn't want to be there, it's going to move up here. When it moves up, I get 1 times a to the third. 1 times a to the third is the same thing as a to the third. I could indeed put it over 1 if I wanted to, but it's not necessary. All right. Crystal. Ready? So I have an, this is a trick one. So do you feel that the negative sitting out in front of the whole problem is going to change the problem? No. But it does have a negative exponent. So what do you know about the negative exponent?
Are we looking at 7?
Yes.
Okay. It's 3, I think.
So, yep, it is negative 4 to the negative 3.
So it will be times 3 times negative.
Well, we're not multiplying because that's an exponent, right? So let's take a look at some of the things we looked at up here. If I had 4 to the negative 2, that became 1 over 4 to the second, so it moved down. So if there wasn't a negative right there, what would you feel would happen to this problem? Using that as a guide, if there's no negative right there.
4 over. No, 1 over 4.
To the,
negative 3.
but it's not going to be negative any longer when it moves down. It becomes this. So now I'm going to bring this negative along for the ride. So that's still going to be negative. So notice the negative here transfers here. Now 4 to the third, anyone have a shot at what that might be? 64, negative 64, I like it. Because 4 times 4 is 16. 4 times 16 is 64. This negative wasn't grouped in any way. It just needs to come along for the ride. So this is going to be negative 1 over 64. Huh. That was a tougher one. Bo, you help us on number 8. We're going to use number 7 kind of as a guide. What do you feel? 1 over 3 to the second. Do you think the negative needs to come? Whoa, time out. Escape it. Negative is going to come down. And then am I squaring the negative 3 or the 3? Now, before you jump on that, let's think about this for a second. Remember sometimes I said your calculator does goofy stuff. Is this a goofy kind of problem? Should that be a negative answer or a positive answer? Somebody have a calculator out? If you have one out, try type in negative 3 and square it on your calculators. Negative 1 over 9. So why did the negative 3 squared become negative 9? What do we need to have in place on that one? Parentheses. We need to group it. We need to have negative 3 inside of the parentheses to square it. Because right now, that's just squaring the 3. The negative is along for the ride. So the answer to this problem is going to be 1 over negative 9. It's a little different. Let's see if we can get number 9 up there. No. Escape. Zoom. and moving. Okay, x to the negative 7, y to the negative 6. Reese, yeah.
How'd you get that again? It was like 2 divided by -2 divided by -3.
Oh, hang on, I gotta get to it. Okay, so do you agree with that?
Yes.
Okay, so 3 squared is 9. So if there was no negative involved, it'd just be 1 over 9.
All right.
But the 3 is the only thing being squared. The negative's not there. If I wanted this to be a positive answer, this needs to be in parentheses. So this negative is going to travel along for the ride. So I'm going to get negative 1 over negative 9, or negative 1/9, or negative 1 over 9.
All right.
Okay? He's got his headlights on. Was it dark outside?
Yeah. I can't see.
Okay. All right. Reese, talk to me about number 9. What do you think? X to the negative 7, y to the negative 6. What do you think is going to go on? X to the negative 7, is it happy where it's at, or does it need to move?
Doesn't it need to move?
Where do you think it wants to move to?
Wants to move to the side to make it like
To the side.
x over 7. X over -7.
Hang on. Let's go back and take a look. So if I had a negative exponent, like if we look here, x to the negative 5, that became 1 over because it became a denominator. It swapped where it was at. This one, a to the negative 3, it moved up. So what do you think is going to happen with x to the negative 7?
It's gonna move down.
It's going to move down. So I get x to the negative 7, which is now x to the 7th on the bottom. What do you think y to the negative 6 is going to do?
It's gonna be y6.
On top. There you go. That's it. Huh. It's not too bad, I don't think. One last thing we're going to do on this. Oh, yeah. Okay. Let's see if we can figure this out. Okay. And move it up. All right. Problem number 10. X to the 4th, y to the negative 5, z to the negative 1. Yo,
That's right.
go ahead.
So would it be, you move negative y to the negative 5th power down?
Okay, and it becomes
Y to the 5th.
downstairs, okay?
And then z to the negative 1st to the top, and then z to the 1st.
Sweet. So this and this are moving. X to the 4th is content. Z to the 1st is now up here. Is z to the 1st the same thing as z? Do you think it's wrong if I keep it z to the 1st? And then y to the 5th is down here. Preston, picking on you again. Number 11. 3 squared seems content, do you think? Okay. What do you think is going to move downstairs? Okay. They're just going to move down. When they move down, do they keep the negative sign? No. The negative just tells you where it wants to go. It's going to switch where its location is. So 3 squared, 9. B to the 5th stays there, over a to the 4th, c to the 8th. What do you think? Ray, pick it on you next. Going to number 12. I'll get there in a second. Thanks for your patience with me. Three to the negative 4. It's going to move down. 3 to the 5th. Stay up. X to the negative 4. All right. So 3 to the 5th, staying upstairs. 3 to the negative 4 comes down here. X to the negative 4 comes down here. Okay. All right. I have a base of 3 on top. I have a base of 3 on bottom. Agreed? So 3 to the 5th is like 3, 3, 3, 3, and 3 being multiplied together. Still with me? 3 to the 4th is the same thing as 3, 3, 3, 3 being multiplied together. So let's have this almost as a little game. We're going to talk about tug of war or tug of war, depending upon which school you went to. So I'm going to do a tug of war between the top and the bottom. The top has 3 to the 5th. The bottom has 3 to the 4th. Who do you think is going to win, the top or the bottom? Top. By how many?
1.
So 3 to the 1st is going to win. So I have 3 to the 1st on top. I still have what on bottom?
X to the 4th.
X to the 4th. Is 3 to the 1st the same thing as 3?
Yes.
Mm-hmm. So this becomes 3 over x to the 4th. Okay. So now we created a game. Let's eliminate the negative exponents by moving things. If it's negative as a whole number, it's going to move to its denominator. If it's already a fraction and it's in the top, it's going to move to the bottom if it was a negative exponent. If it was on the bottom and a negative exponent, it's going to move to the top. Okay. So let's walk through number 13. Celine. Whoop, hang on. Uh-oh. Whoa, time out. Escape. Color mode, huh? Blackboard game, presentation, text, theater, photo. Oh, I don't know. It's right before game. Blackboard. That looks better. All right, Celine, coming to you. Still with me? All right, that looks like 2 to the 3rd. Is that content where it's at?
Yeah.
4 to the negative 2. What's going to happen there? It's going to move to the bottom. C to the negative 3. Move it to the bottom. D to the 2nd. Keep it there. What's 5 to the 0? 1. F to the negative 1. Move it to the top. X to the 6. Stays there. I like it. So some things move. One of them became 1, and some things stay where they should be. All right. So 2 to the 3rd, pretty content. And I'm going to do this. 4 to the negative 2 becomes 4 squared. Still with me? C to the negative 3 is moving down. D to the 2nd stayed up there. 5, this right here was 1. F to the negative 1 comes up here. So F to the 1st. And X to the 6th. Okay. 2 to the 3rd is 2 times 2 times 2. 2 times 2 is?
4.
Times 2?
8.
Okay. So I have 8 on top. On bottom, 4 squared is? 16. Look at these letters, though. F and F to the 1st, same thing. C to the 3rd, X to the 6th. Is there anything up there that's going to reduce? 8 and 16 reduces to what? 1/2. Are any of the letters in a tug of war? No. So the 8 and the 16 are going to reduce to 1 over 2. And then on top, I'm going to get D to the 2nd, so I don't need a 1 up there any longer. And an F. And C to the 3rd, X to the 6th. Woo!
But why wouldn't you need 1 up there?
I could put it up there. I could put it right here if I wanted to. It's not necessary because I already have other stuff in there. The only reason you wanted 1 is if everything moved to the bottom to keep it as a placeholder. If you put it there on a test, 1D squared F, totally right. Nothing wrong with it. Some teachers later, though, might like, oh, you don't need 1 here, so that's 5 points. I'll be like, Mr. Stirrup. Hey, pay no mind to what Mr. Stirrup said. He's an idiot. They might be right. I'm sure the village is missing me someplace. All right. Ready? Casey, let's walk through this one. X to the 7, is it okay where it's at? Okay. M to the 3rd, is it okay where it's at? Okay. Y to the negative 3, is it okay where it's at? No. What does it want to do?
Wouldn't they cancel each other out?
Not yet. Oh, I see that. let's get rid of the negative exponent. You're absolutely right, but let's get rid of the negative exponents first. So what does y to the negative 3 want to do, the one on top? What does it want to do? No. Y to the negative. If I just had y to the negative 3, what would I want to do to get rid of that negative exponent? Put it in a fraction because it's moving down. So I like what you said that they're going to cancel. I had y to the negative 3, y to the negative 3. If they flip-flop, that becomes y to the third, y to the third. And y to the third, y to the third on top and bottom do what? Cancel. X to the negative 3 does what?
Go up.
Moves up. M to the 7, okay?
Yeah.
All right, so let's see. I'm going to escape out of here. So I like that this and this are gone. They cancel each other out. And then I have x to the 7, m to the 3, x to the 3 on top, and m to the 7 on bottom. So if I were to combine my like terms, I have like bases that I'm multiplying together. So what do I do with the exponents? Add them, so what do I get on top? X to the 10 on top. Now I'm going to create tug of war between the m's. Who wins, in your opinion, top or bottom? Bottom by how many? 4. Done. Sweet. Caroline. All right. So what I want you all to work on, try to work on, and you have the rest of the period to work on this, is, uh-oh, here they come. Everyone hide. Is number 14, worksheet number 14 is page 29. Is that just one? So it's 2 pages. It looks like 23 questions. So you have 1 through 12 on one page and 13 through 23 on another page. If you have the opportunity to work on it now, please do. If you don't have yours with you, get with somebody who has theirs and just copy it down. I'm going to start saving this bad.